Okay, in this video I'm going to talk about the equation of Coulomb's law, and also I will be solving one example to compare between the electrostatic force and the gravity force between two charges or two charged objects. Coulomb's law describes the electrostatic force between electrically charged particles. That means in order to be a force or an electric force, the particles have to be charged and you have to have two particles. And in this case, we could have one positively charged and we could have one negatively charged particle. Any two charged particles will do the job, whether they are two positively, two negatively, or one positive and one negative charge. The two charged objects will exert a force on each other. For example, they are oppositely charged, so they are going to be attracted to each other. The arrow represents the force that this particle feels from the other particle. So in our case here, you can see that this arrow here representing the electrostatic force, charge number 1 feeling or experiencing because of charge number 2. The same scenario, this arrow here, the electrostatic force representing the electrostatic force coming from charge 1 on charge 2. And because the direction of each of these arrows going away, that means these charges have a repulsive force or repulsive electrostatic force between them. Now, just a few items. The force they are going to experience is going to be opposite in direction, equal in magnitude in this case. The electrostatic force, it's one of the vector quantities. And something just to keep in mind, if I call Q1 and Q2, that means the force, if I want to calculate or find the force generated by Q2 on Q1, which one will be this one here, all right, I will say it's F12, and I can write down that like this if I want to. I can say this is F12. On the other side, I can say it is F21. Let's discuss this one and we compare it to the other one. So if I say F12, that means it's the force on 1 because of charge 2, where here it is the force on charge 2 because of charge 1. Okay, now the way we calculate the Coulomb's force, or the force acting on a charged particle from one to another particle, is using Coulomb's formula, which we see here at the middle. I'll open the laser again. This is the formula we use to calculate this electrostatic force between the two charges. We called Coulomb's formula. Now, just to identify the items, the Fe, it's representing the electrostatic force exerted on one charge because of the other. K here, it's the constant, or it's Boltzmann constant, and it's a specific value, and it is K equal 8.9 10 to the power 9, and the unit is Newton per meter square. Sorry, it's meter per square, meter square per Coulomb square. So that's the constant K. Now Q1 and Q2 is the two charges and the unit is Coulomb, and this R is the distance between the two charges. Just some conceptual items. You can see from the formula here that the electrostatic force between the two charges has a proportional relationship with the magnitude of the charges. So the bigger the charges we have, the more electrostatic force we have. It doesn't matter if it's a negative or positive. We take the absolute value, but the magnitude, we care about it. Now, the other thing, the electrostatic force between the two charges has an inversely proportional to the square of the distance between the two charges. So it is 1 over r squared. Also, we can compare the electrostatic force with the gravity between two objects and the law of the gravity as how they look like. That equation will be, if I want to write it, I can say it's Fg equal the gravity constant m1 m2 over the distance between the two objects. Just to give a touch on, they do really look alike. Okay, this is what is to do with Coulomb's law. In this next slide, what I'll do, I will start to solve a simple problem related to the two charges, calculating the force between them, and compare it also to the gravity force. Now I have two 0.5 kg spheres are placed 25 centimeters apart. Each sphere has a charge of 100 microcoulomb. One of them is positive and the other is negative. The first part of the question asking me to calculate the electrostatic force on the second sphere because of the first one. The second part of the question telling me compare it, which is the electrostatic force, to their weight. So I will say, as a start, it's really good to draw or sketch a small diagram representing the scenario. I'll say this is my positive charge. Here it is. That's my negative charge. It is a positive 100 microcoulomb. This one, it's a negative 100 microcoulomb. The distance between the two charges, it's a 25 centimeter, which is equivalent to 25 10 to the power minus 2 meter. Now let's apply. Let's call this is Q1, this is Q2, just to distinguish which one is which one. So I'm trying to find the electrostatic force on the second sphere. So it's because it's negative, there will be an attraction between them. So the force will be this way. That's the force on 2 because of 1. So if I want to calculate that, it will be F21 equal K Q1 times Q2 over R squared. Let's place the values. It's 8.9, 10 to the power 9, 100, 10 to the power minus 6, also 100, 10 to the power minus 6. All this divided by the distance squared. And if we do the calculation, that should give me 1,424 Newton. Okay, now for the second part, it's the weight, Fg, it's the mass times the gravity acceleration. It is 0.5 kg times 9.81. This should equal 4.9 Newton. And you can see how big is the electrostatic force between these two charges or these two charged spheres compared to their weight. I hope you like this video and you find it useful. Thank you.